All right, welcome. We're going to talk about power today. So power is the rate at which work is done. The formula that we use for power is work divided by time. Okay? So if we think about it, how did we get work?
Oh, no.
Come on. You got this. Work is equal to force times distance, right? And then power is work divided by time. So it's almost like we have to use, and this is the key to these problems, is you have to use your F net equations to get your F net. You have to use the F net and the D to get work. And you have to use work and time to get power. So these are really, in order to get to power, we need 3-step problems, okay? Some of these will be harder than the others. But really, it's one extra step upon what we've already learned. So we talked about the unit. Power is work divided by time. There is a unit for it that is called a watt. Okay, and a watt is, if you think about it, work divided by time. What is work measured in? Joules, right? And what's time measured in? Seconds. So technically, it should be measured in a joule per second. But it is not, because we renamed a joule per second, which is a watt, okay? If you really want to break it down, we know that a joule is equal to kilogram meter squared per second squared, and we're dividing by seconds. So technically, a watt is a kilogram meter squared per second cubed. Remember, force was kilogram meter per second squared. Joule was kilogram meter squared per second squared, which was for work, right? And power is just divided by time. Yes, question?
So, if that's on the quiz, you want the bottom and not joule per second?
I think, yeah, we're probably going to ask for that. But you can get it using the formulas if necessary. What was that? Can I move?
Yep. Thank you.
Yeah, she's being feisty today, ain't she? Yeah. Yes. Tone it down, girl. Bring it down one notch, okay? All right. We don't mind feisty you, but uber feisty is where we get. Disrespectful is where we draw the line. Okay? So that said, there's an alternate formula if you think about it, and we'll go ahead and we'll talk about this alternate formula real quick, okay? So power is equal to work divided by time. We talked about that, right? But work is actually equal to force F times D over T. So if you guys look here, right, what do we call D over T? Velocity, right? So technically, there would be two formulas that you could use. You could use the force times velocity formula also, okay? Yeah. What is the abbreviation for watts? It's a capital W.
Okay, and then work is a lowercase.
Work is also a capital W, which stinks, but you got a capital W and you got a capital W, but they're for different things. One's for a unit and one's for a variable, so that's acceptable. I don't love it, but it is what it is. So, since there's multiple forces and multiple works, then there's multiple powers, okay? So, if you think about it, if I was looking at a very basic problem where something was being pulled one way and then there was friction the other way, then we'll talk quickly about the multiple work situation. The free body diagram in that situation would be F pull and Fk going back this way, okay, for kinetic friction, right? So in that case, we would actually have 3 different works happening. There would be the work done by the pull. There would be the work done by kinetic friction, which is taking energy away from the system, right? This is giving energy to the system. This is taking energy away from the system. And if they are not equal, then there will be net work done on whatever object is happening, okay? Just like when there's two forces, there's force pull, force Fk, and there's net force. So in each one of those situations, there would be work getting done. Well, that work happens over some period of time. So technically, there's pulling power there's power done by friction, and there's net power done on the object. So what they're saying here, when it says, since there are multiple forces and multiple works, then there's multiple powers. What they're essentially saying is, you have to, just like we were very careful to distinguish what work we're solving for and what work we're putting in the problem, we're also going to be careful about making sure that when we read a problem, that whatever power they tell us it is, that we use a little subscript to make sure. Because the formulas always have to match the powers always need to match the works. So that said, I want to do a problem or two. I'll do one. You guys can do two. We'll do three together. You guys can do four. We'll do a few of these until you feel comfortable with them, okay? So that said, I'll start with this first one. It says a pool pump uses 67 watts of power. Look what I do. Power, P. PP, right? Okay. Ha ha ha. So funny. Yes. Okay. But yes, PP stands for the power of what? Pump. Good. Okay. We said it was 67 watts. Okay. And then we've got pulling a mass that is 13 kilograms up a distance or a displacement of 6 meters. Either one is fine because it only moves one direction. Okay, it says it moves at a constant velocity. That tells me that its acceleration is what? Good. Okay, and that would be AY because we're moving in the Y direction in this spot. The pump is pulling the water upward. Okay, and then it says how long does it take the pump to do this? So that said, I'm going to go ahead and I'm going to do this. I'm going to draw a free body diagram. If the power of the pump is pulling upward, then there must be the force of the pump pulling upward, right? In addition to that, we have a force going down. What force is pulling the water down? Gravity, good. All right, so if we have the force of gravity pulling it down, then in that situation, we actually have to, I'm going to look at the formula, power pump equals work pump divided by time. So this said, if we want time, then we have the power, then we could get, all we need is the work pump. Do we have the work pump in our givens? Okay, we do not have the work pump in our givens, okay? So that's the problem. So we got to fix that, all right? So let me fix this. Oh boy. All right, so if we have work pump, we need to get work pump. So I'm going to do that. I'm going to do work pump is equal to force pump times distance. So we know the work is equal to force pump times distance. Well, we have the distance, but we don't have the force pump, do we? So right away, I'm going to look down here, and I'm going to look at this free body diagram. And I'm going to say, well, I've got a free body diagram, so I can write an F-net equation for that. So my F-net equation would be equal to force pump minus force due to gravity. I'm going to put MA in here, but I know the A is 0. This is what I'm solving for, because if I can get that, I can get that, which can get that. So then I don't know FG, but I do know FG is equal to mg. So when I do the math, my force pump is equal to mg, and my M is force pump is equal to mg. I'm adding mg to both sides. So the force pump is the mass, which is 13, times 9.81. The force pump is equal to 27.53 newtons. So now we've started the process. If we've got this force here, then we just plug that force in there. We have the D, we can go get the work. We have the work, we can plug that in there. We have the power pump, we can get our time. Okay, so that's what I'm going to do. I'm going to go back up here, and I'm going to do work pump equals force pump times D. And my work pump is equal to 127.53 times my distance, which is 6. And the work pump ends up being
76.20
joules, okay? And then last but not least, we're going to do power pump equals work pump divided by time. And our power pump is 67. This is 765.18, and I'm solving for the delta t. The way I'm going to do that is I'm going to multiply both sides by delta t, and I'm going to get 67 delta t is equal to 765.18. Divide both sides by 67, and we get a time that is equal to 11.42 seconds. Is that right?
Yes.
And we've got our answer. Okay? So, power is one step above what we did. We've learned how to do free body diagrams and F-net equations. Those are going to come into play in most problems. Okay? In addition to that, we've learned that work is equal to force times distance. So that will come into play. And then you'll make the next step and go power equals work pumped divided by time. You're going to do some combination of all of these. Now, some problems where you'll be given one thing and have to work to another. Every problem is different, but every problem is going to involve a free body diagram, an F-net equation, the work formula, and the power formula. You just have to be creative and find a way to use all those to get where you need to get. Okay? So you guys go ahead and try number 2, and I'm going to help you out. Do the givens first. You can check your givens with mine. Do your free body diagram next. You can check your free body diagram with mine. F-net equation, you can check yours with mine. And then we're going to solve for the missing value.